Hello students, my name is Mr. Abiyantana. Welcome to grade 11 Mathematics Unit 1, which is about inverse function and their graphs. So we'll try to discuss on invertible function, when a given function is said to be invertible or when it will have the inverse. So, and also how to find inverse of invertible function, and also graphs of inverse functions, the properties, how we can draw inverse graph for a given functions. So what's invertible function? A function is invertible if it is one-to-one. If it is one-to-one, we can say a given function is invertible, meaning its inverse is also a function. So how we can find inverse of a given function? F of x equals to y. So if f is invertible, meaning if it's one-to-one, then to find its inverse, interchange x and y in the expression y equals to f of x. That is, we write x equals to f of y. Then after, we'll solve y in terms of x if possible. Sometimes there are functions which cannot be solved y in terms of x. So if possible, we'll try to solve y in terms of x. Then finally, we'll write f inverse as y equals to f inverse of x. Now, we have example 1. Find the inverse of f of x equals to x plus 1 over x minus 5. So to find inverse of this function f of x, we'll interchange a place of x and y. Sometimes when the function is written like f of x equals to x plus 1 over x minus 5, in place of f of x, we can write y equals to x plus 1 over x minus 5. So this is a given function. So to find the inverse, interchange a place of x and y. So we can rewrite x equals to y plus 1 over y minus 5. So to solve y in terms of x, let's make it a recross. So it will be x times y minus 5x equals to y plus 1. Then after, let's combine terms containing y to the same side. X minus y, let's bring this y to the left-hand side, minus y equals to 5x, then plus 1. Now look, from the left-hand side, we have a y, which is a common. So if we factor out y, so it will be x minus 1, which is equal to 5x plus 1. So to solve y, if we divide both sides by x minus 1, both sides by x minus 1. So we'll have this result, y equals to 5x plus 1 over x minus 1. Then finally we can write f inverse of x equals to 5x plus 1 over x minus 1. So in general, here the technique is, in place of f of x, you can write y, that's equivalent. Then after rewrite in this form, we'll interchange a place of x and y. Then after, using the same technique, we'll solve y in terms of x, if it's possible. If it's not, we can write as it is. Then what is the property of inverse function? Let two functions f of x and g of x are inverse to each other. Then f of g of x, which is a composition function, equals to I of x, which is identity function, which is equal to g of f of x, where I of x is an identity function, which equals to x. It maps every input to itself. That's what we call its identity function. Then example 2, if f of x equals to x over 3 plus 2 and g of x is 3x plus b are inverse to each other, then find a constant b. So if the two functions f of x and g of x are inverse to each other, what is the property of inverse function? A composition of g of f of x equals to an identity function that is x, and this is also equal to f of g of x. So by applying this property, we can find a constant b. So g of f of x means substitute the function f of x in place of x in the function g. So that is 3 into x over 3 plus 2. Then we have a constant b. This must be equal to an identity function x. Either we can use the second option. So finally we'll have the same value, so we can use either this one or the right hand side of the equation. So this equal to 3x over 3 then plus 6 plus b equals to x. We have this simple linear equation. So this is x plus 6 plus b equals to x. Now we can cancel x on both sides, meaning we can subtract x on both sides, so it will be reduced to 6 plus b equals to 0. Then we can solve for b. b equals to negative 6, which implies to be the function f and g are inverse to each other, a constant b must be equal to negative 6. A graph of inverse function. What looks like a graph of inverse functions? If f and g are inverse to each other, then a graph of one is the reflection of the other along the line y equals to x. So there are steps to draw graph of inverse function. The first one, draw graph of a given function f of x. Then secondly, reflect a graph of f of x along the line y equals to x. The image is a graph of inverse function. Now look these two graphs. We have a graph here, and this is a line y equals to x. So if we observe these two graphs, one is the reflection of the other along the line y equals to x. So in general, if we have a graph which is symmetrical with respect to y equals to x, one is inverse of the other. Any graph, if it is symmetrical with respect to y equals to x, one is inverse of the other. Even we can check, this is f of x equals to the power of x, and the image function f inverse of x is log x to base 2. Look, the first function y equals to the power of x. Then how we can find inverse of this function? We can interchange x and y. So x equals to the power of y. So if we compose both sides by logarithm to base 2, logarithm of x to base 2 equals to logarithm of to the power of y to base 2. So if you remember a law of logarithm, logarithm of to the power of y equals to y times logarithm of 2 to base 2. But logarithm of 2 to base 2 is equal to 1. Therefore, if this is y equals to a logarithm of x to base 2. Now we can write f inverse of x equals to, that is logarithm of x to base 2, which implies f of x equals to the power of x, and this function f inverse of x log x to base 2 are inverse to each other. And graphically, one is the reflection of the other along the line y equals to x. Look graph of these two functions again. A graph of f of x equal to 2x minus 4 is this one. This is a graph of f of x, and a graph of g of x equals to x over 2 plus 2 is this line, and the two graphs are symmetrical with respect to the line y equals to x. So if they are symmetrical with respect to y equals to x, one is the inverse of the other. One is the inverse of the other. In the same way, we can check whether these functions are inverse to each other or not. Let's check whether they are inverse to each other or not. F of x, that's y equals to 2x minus 4. So to find the inverse of this function, let's interchange x and y. X equals to twice of y minus 4. So if we need to solve y in terms of x, let's rewrite x plus 4 equals to 2y. So if we solve y equals to x plus 4 over 2. So this equal to y equals to x over 2, then plus 4 over 2 is 2, which is the same with this function. So even without finding the inverse of a given function, we can draw its graph by reflecting along the line y equals to x. Or to check two functions are inverse to each other or not graphically, check that the two graphs are symmetrical with respect to y equals to x. Then the other one, how we can even check by taking some points. Let's take some points on f of x and whether that points are on a graph of its inverse or not. Now we have this point. Look this point. This is a point which is 0, minus 4. If this is a point which is 0, minus 4, it is a point on a function f of x. What is the inverse of this point? 0, minus 4. So inverse of a given function is obtained by interchanging x and y. So if we interchange these coordinates, what will be the coordinate? That's minus 4, 0. Look, where is minus 4, 0? It is on a graph of its inverse. And we can take another point. Let we have this point which is 2, 0. That's a point on a graph of f of x. And what is the inverse of an order pair 2, 0? So the inverse is obtained by interchanging x and y. So its inverse must be 0, 2. Let's see where is a point 0, 2. A point 0, 2 is on a graph of g of x. So we can take some points on f of x and we can check its inverse point is on the graph of g of x. This one is exercise for you. Find inverse of function f of x, x plus 1 over x minus 2. Follow the procedures and check your answer. Its inverse is y equals to 2x plus 1 over x minus 1. And the second question, let f of x is x over 5 plus 2 and g of x equals to ax plus b are inverse to each other. If they are inverse to each other, then what are the values of a and b? Here to find a and b, apply a property of inverse function. If two functions are inverse to each other, a composition of one with respect to the other must be an identity function which is equal to x. Then another exercise 3, the inverse of the function defined by g of x equals to 2x over x plus 3 is equal to which? So find the inverse for g of x and check your answer. The answer is B. So in general, we have seen these points. A function is invertible if it is one-to-one function. Otherwise, it's not invertible. Invertible meaning its inverse is also a function. So if f and g are inverse to each other, then graphically one is the reflection of the other along the line y equals to x, or symmetrical with respect to the line y equals to x. This is all about the presentation. See you next time. Do more exercise and practice.